So first, we're going to make our stock solution. So we are making a stock solution of cobalt-2 chloride hexahydrate. So again, there's 6 water molecules attached. And this is a pink solid, a very obvious color to it. And we are going to put in a number of grams to make a stock solution into a 250 ml volumetric flask. So you have to figure out how many grams I have massed out there to make our concentration. So what you will see is I'm going to use a funnel just so that I can easily pour it in there. And then I'm going to add water to the line. Add water to the line. So now we're going to make up our solutions A through E. And following the lab, it will tell you how many milliliters you're going to put into each one. And we're going to start with our stock solution that we made in the 250 ml volumetric. So in this video, I'm just going to show you solution E, and everything else will follow the exact same procedure. So I'm just going to pour some of the stock solution into a beaker just to be easier to pipette out of. And then for E, if you look up on your lab, you will see that the volume that we're going to pipette is about 20 milliliters. So we're going to use a volumetric pipette that I'm trying to show you in the camera. That's 20 milliliters. So I'm going to put it into the beaker and suck up 20 milliliters up to the line. And then I'm going to dispense it into the volumetric flask. So all 5 of our dilutions have been prepared, A through E. A is the strongest concentration, E is the weakest, and you could tell by the color. So we are now going to take the stock solution and find our Lambda Max. So we're going to take whatever we have left over of our concentrated solution, and we're going to use the spectrophotometer to find the wavelength that we need to read our samples at. So we're going to start with a nanometer of 450, and we are going to use a blank in order to set our spectrophotometer. So this is distilled water, and I've wiped the outside with a chem wipe, and I'm going to put it into the spectrophotometer, and I'm going to hit the button, and I'm going to set it to 100% transmittance, but we're going to focus on 0 absorbance for this one. So this is all going to be an absorbance. So now I have 0 absorbance, and I'm now going to put another cuvette in there. This cuvette contains the stock solution. That's from that volumetric. And I'm going to read the absorbance in the screen and write down that number. Then I'm going to take the sample out of the compartment, and I'm going to blank again. Anytime I change the nanometers, so I'm now going to change the nanometers to 500 nanometers, and I'm going to see what the absorbance is at that. Every time I change the nanometers, I have to re-blank the spectrophotometer. So what you will see is I'm going to put a cuvette with distilled water into the compartment, and I will blank it again and then read my sample one more at the new wavelength. So now we have our Lambda Max, we're going to read our samples. So in this video, I'm just going to show you solution E. So it's been determined that our Lambda Max for this solution is 510 nanometers. So we're going to read all of our samples at that wavelength. So for every spectrophotometer, we need to blank the spectrophotometer first. So what you're going to see is I'm going to put a cuvette with distilled water into the compartment, and it's already been wiped with a chem wipe. And then I'm going to hit the button and zero it out. So you're going to see blank show up in the screen. Now that it's been blanked, all I have to do is read my samples. So in this video, you're just going to see me read solution E, but all of the solutions, including the unknowns, are going to be read on the spectrophotometer at 510 nanometers. So all I have to do is write down the numbers.